Welcome to lesson 2:2, adding integers. Right, so we're going to take the subtracting part of it out of today and we're just going to talk about adding integers. So after today's lesson, you should be able to demonstrate adding integers on a number line, add integers, and solve problems that involve adding integers. Alright, so rules. We need to know that there are specific rules that go with figuring out the sign of an answer to an addition problem. These rules are different than those rules for multiplying and dividing, so it's really important that you practice them so that way when you're using them, you're making sure to put the right rules together. So first, I have a positive plus a positive gives me a positive. This makes sense. You've been doing this your entire math career. You know that 2 plus 2 is 4 and that they stay on the positive side. And we'll kind of show some reasoning behind that when we work on the number line. A negative times a negative, or plus a negative, is going to give you a negative. Okay, so once you're to the left of that 0 and you add another number to the left of the 0, you're going to keep going left, and so you're going to stay on that negative side. Positive plus a negative, though, the sign of the bigger number. Now I put bigger in quotes because the number actually isn't bigger. So what we're actually going to say is the sign of the number with the larger absolute value. So the sign of the number with the larger absolute value. Okay, so the answer takes the sign of the number with the larger absolute value. And we'll talk about this a little bit more later on. All right, so when we're using integer chips, how would you represent -3? Well, my red chips are the negatives, so I would just grab 3 negative chips. For positive, since positive is yellow, I would grab 2 yellows. And now with 0, you can't represent 0 by just putting nothing. So I would represent it by showing that a negative and a positive combined, they undo each other, and so you end up with 0. So if you have one positive and one negative, you end up back at 0. Right? So this is like the additive inverse. If you have the same amount of positives and the same amount of negatives, you actually have 0. All right, so if I have -3 plus -2, we have it demonstrated here. You started with 1, 2, 3, and then you added 2 more. Well, I don't have any positives in the problem to undo the negatives, so I end up at -5. Again, a negative and a negative gave me a negative. Here, though, I have -5, so I have my 5 red chips, plus a +3. So here I have 3 positive chips, so I have to look and see how many negative chips is that going to undo. Well, these 3 undo each other, but I'm still left with 2 negative chips. So I know that -5 plus a +3 gives me a -2. All right, again, looking at this, following my rules, I know that -5 has an absolute value of 5. And 3 has an absolute value of 3. Since this one has the larger absolute value, then we keep the negative sign in our answer. All right, so -4 plus a +6. Again, looking at all of the chips that undo each other. So we have 4 negatives that are going to undo 4 positives. And then I still have 2 positive chips left, so I know that my answer has to be a +2. And again, if we look at that rule with absolute value, the absolute value of a -4 is 4, and the absolute value of +6 is 6. Since this one has the larger absolute value and it's positive, my answer has to be positive. All right, so now let's look at this in terms of a number line. First, we have to remember that adding, so the addition symbol or positive tells us to move right of 0 or actually right in general, and the subtraction sign or the negative sign tell us to move left. So we're going to keep this in mind and we're going to put it to use when adding using a number line. All right, so we added using number chips, but typically we're not going to have little red and yellow chips lying around. So we're going to practice with a number line so it helps to make a little bit more sense, and then we'll go from there. So here I have 4 plus negative 3. So when I'm demonstrating this, I always start at 0 because that's where we start when we count on a number line, unless otherwise told. But here I start and I go 4 places to the right because this is a positive 4. So I go 4 places to the right, so 1, 2, 3, 4, and then I put an arrow. Now, since it's plus, it tells me to go right, but this negative says, nope, you're going left. And I'm going to go left 3. So I start at the 4 and I go left 3 spaces. So 1, 2, 3. And I end up at 1. So I know that 4 plus a negative 3 is 1. All right, so here I have a negative 6, so the negative 6 tells me to go left, so I go left 6 spaces. Oops, and I started at the 1, so that would change my answer just a little bit. So I start at the 0, and I go 6 spaces, 5, 6. And then the plus sign tells me to go right, but then the negative says, nope, you're going left. So I continue to go left 4 more spaces, so 1, 2, 3, 4. And I end up at negative 10. Well, this follows my rule that a negative and a negative gives me a negative, because what's ending up happening is even though plus tells me to go right, the negative tells me that I'm actually going to continue going left. So I end up at negative 10. Okay, and then again here, checking out my rules. So let's just jot this down. This would be a good idea. I know that negative plus negative gives me a negative. And here, the absolute value of 4 is 4. The absolute value of negative 3 is 3. So since 4 has the bigger absolute value, I know that my answer has to stay positive. And it did. Here I have a negative and a positive, so let's use our rules. So absolute value of 8 is 8. The absolute value of negative 7 is 7. So since this has the larger absolute value, my answer should be positive. So when I finish this, I should end up on the right side of 0. So here, the negative sign tells me to go left, so I go left 7 spaces. 3, 4, 5, 6, 7. And now, this tells me to go right, and I have no negative sign to change that, so now I go right 8 spaces. So 1, 2, 3, 4, 5, 6, 7, 8. And I ended up at positive 1, which makes sense because my answer is supposed to be positive. And if you think about number chips, you have 7 of the negatives, 4, 5, 6, 7, and 8 positives, 1, 2, 3, 4, 5, 6, 7, 8. All of these cancel each other out, and you're left with 1 positive left. Right? So all of these ways that we've used to understand adding integers all end up with us getting a positive 1 as an answer. Right? But what I want to look at now is how did I get these answers? How can I get these answers when I don't have a number line and I don't have number chips? So what I'm going to do is I'm actually going to copy this page, and we're going to work on getting these answers again. And so I'm going to go ahead and I'm going to clear all the writing, and I knew that this is supposed to be 1, negative 10, and 1. So looking at the numbers 4 and 3, is there any way that you can think of to get to 1? If you said subtraction, you'd be correct. When you have numbers that have different signs, you actually subtract to get your answer. So I'm going to type this out so it goes a little faster, and I would suggest you write this down somewhere. I'm not going to write it down that large. There we go. So when you have numbers with different signs, you subtract to find your answer. So I shouldn't say when you are adding numbers with different signs, you subtract to get your answer. So here, I'm going to ignore the signs, and I'm just going to do 4 minus 3. I'm just going to subtract the absolute values. And actually, let's add that to our statement. You subtract the absolute values to find your answer. So the absolute value of 4 is 4, and the absolute value of negative 3 is 3, and so I subtract and I get 1. Since we know that the absolute value of 4 is larger, I know my answer has to be a positive 1. Well, here I have a negative plus a negative. When your signs are the same, you just add and keep your sign. So when adding numbers with the same sign, you add and keep the sign. You add the absolute values and keep the sign. There we go. So here I have negative 6, and the absolute value is 6, and I have negative 4, and the absolute value is 4. So I add and I get 10. But since both of these were negative, so negative and negative, I know my answer has to be negative 10. And I'm getting the same answer as I did when I did it on the number line. So here we have different signs. So I know that I have to subtract. All right, so the absolute value of negative 7 is 7, and the absolute value of 8 is 8. So I'm going to do 8 minus 7, and I get 1. Since 8 has the larger absolute value, my answer has to be positive. So my answer is positive 1. Okay, this does seem a little bit tricky and can get a little bit difficult at times and can trip you up a couple of times, but as you practice this, it will make more sense and it will become easier. All right, so let's take a look at when you have an actual problem that involves negatives. So for helping to plant her mother's garden, Lisbeth was paid $10. She also owed Brooklyn $12. How much money did she have left? Okay, so I want to know the answer to the question of how much money did she have left? And I know that 10 is important and 12 is important, and I'm going to underline paid and owed. And have left, I'm circling because it tells me what to do. So typically we would look at this and say, well, let's subtract. Well, as a subtraction problem, this becomes 10 minus 12. And we're not dealing with subtraction. Subtraction is icky. I'd prefer to add. So we're going to go ahead and set this up as an addition problem. So you have to look at the integers. And since she's paid $10, paid means it's positive. So she has a positive $10. Owed means it's negative, so it's a negative $12. And so what we're going to do is we're going to add the $10 that she earned to the $12 that she owes. And I know that that means I do 12 minus 10, which is 2. But since 12 has the higher absolute value, I'm just going to put AV for short, that she still has, so she has a negative $2. She still owes $2. Moving right along, we're going to try a couple of these and then I'm going to let you head out on your own. So 2 plus 7. Well, we know that a positive and a positive, we can do this in our sleep. That's 9. We just add like we normally would. Here, my signs are different, so that means I subtract. And since I don't have enough positives to undo my negatives, okay, so we can look at it in terms of our chips. I don't have enough positives to undo my negatives, so I know my answer should be negative. Or I can look at my absolute values. It's the same idea, it's just looking at it different ways. The absolute value of 4, or of negative 4, is larger than the absolute value of 3, so my answer has to be negative. So now I've set it all up and I know that I'm going to subtract because I have different signs. And I know that my answer has to be negative. So I'm going to subtract 4 minus 3 and I get 1. But since I know my answer is negative, I know my answer is negative 1. And again, you can double check that by getting a colored pencil and saying, okay, here are 4 negative chips and I have 3 positive chips. These two give me 0, 0, 0. I'm left with negative 1. Okay, so different signs tells me to subtract. And I know that negative 17 has an absolute value of 17, and 12 has an absolute value of 12. So my answer, once again, is going to be negative. So I'm going to subtract 17 minus 12, and I get 5. So I know my answer has to be negative 5. All right, so different signs tells me I should subtract. Negative 1 has an absolute value of 1. 6 has an absolute value of 6. So my answer should be positive. I know I'm subtracting my absolute values and I get 5. So my answer is positive 5. Different signs. So I subtract. And I know, so again, I really want you to focus on understanding why your answer is positive and why it's negative, and understanding what's going on. For every positive and negative that you have, they undo each other. So if you have the same amount of positives and negatives, you have 0. Right? So the absolute value of 4 is 4, and the absolute value of negative 5 is 5. So my answer is going to be negative because I have more negatives than I have positives. So I don't have enough positives to undo my negatives. So it's a negative answer. I subtract my absolute values and I get 1. So my answer is negative 1. Oh, lovely. Same signs, so I just add like normal. So same signs, so I add, so I ignore, so I just add 57 plus 25. I add my absolute values, and I get 82. But since they're negatives, I know my answer has to be negative, so it's negative 82. All right, so we have a couple of problems here. And what I would like you to do is I would like you to set up an expression to represent this problem. So you have to have two things. You have to have the expression, and then I'd like you to answer. So expression, answer. And I want you to pause and try this, and then when you come back, we'll check your work. All right, so the team loses 3 yards, and on the next play they gain 2 yards. And we want to know what is the change in yardage after the 2 plays. Okay, so what is the change in yardage? So what ended up happening? So the losing 3 yards means that I have a -3. But then I gained 2 yards, which is a +2. And so I want to know, when I put those together, what is my total change? So here's my expression. It's the negative, so it's the loss of 3 yards plus the gain of 2 yards, because we want to do addition expressions, because we have rules for addition. And we'll talk about subtraction later on, but you'll find we end up working with addition. All right, so we have -3 and +2, so we end up subtracting, and I get 1. Since -3 has the higher absolute value, my answer has to be -1 yards. All right, so you have a couple of problems that I would like you to try on your own. We have these problems here, so I'd like you to add and find an answer. And then I'd like you to demonstrate how to show addition on a number line. Okay, so add, demonstrate on a number line. And then you also have this word problem here. A submarine is 86 feet below sea level. The submarine then rises 16 feet and dives 58 feet. What integer describes the position of the submarine? So I want 2 things here. I want an expression to demonstrate the change in depth, and I want the change in depth. Okay, so you're giving me an expression and you're giving me an answer, just like we did for the football problem. As always, if you have any questions, be sure to write them down or email me so we can go over them in class.